Okay, so we're looking at this question. If you haven't already done so, please pause and have a go. Now, show that the center of C has coordinates 3, 6. That's very straightforward. It's just the midpoint of the diameter, and we're given that AB is a diameter. That's very straightforward. It's going to be 8 plus minus 2, which is 6. Half of that, 3. 11 plus 1 is 12. Half of that, 6. So that's question 1 mark, easy question. Part B, find an equation for C. Well, we know the center, but we need to know the radius. Okay, so the radius, if we say that what is the distance, or let me just remind you, x minus a squared plus y minus b squared is equal to r squared. Now the radius squared, the square of the radius is all we need. So let's work that out. Okay, so we can say what is the square of the distance between B and C, for example, or the center of the circle. Let's just do that. 8 minus 3 squared, so r squared is equal to 8 minus 3 squared, 25, brilliant, plus, it doesn't matter which way around here, again 25, so that is equal to 50. Okay, so now we have our center and we have our radius. We can say that the circle has equation x minus 3 squared plus y minus 6 squared is equal to 50. Done. Now for part C, we have to verify, so you can make that a bit clearer, that the point 10,7 lies on C. So it has to satisfy the equation of the circle, which we already found in part B. So when I substitute the value of x is equal to 10 and y is equal to 7 into this equation, I should get 50. So let's do that. 10 minus 3 squared, 10 minus 3 is 7 squared, plus 7 minus 6 squared, which is 1 squared, if you like, which is just 1. Therefore, 10,7 lies on C. Lies on C. Okay, very straightforward. Now the last part wants us to find an equation of the tangent to C at the point 10,7. Let me just draw a circle and a tangent just to get a little picture of what we're talking about. Okay, so just roughly, supposing that this is the circle, our circle, so rough sketch. The center is 3, 6, and this point is, let's call it P, has coordinate 10, 7. Now we want the equation of this line, this straight line, tangent at P, the tangent to the circle. Now supposing I didn't have a circle, but I had a chord. Let me just shift that over. How would I work out the 2 points of intersection of the chord? Simultaneous equations. So if I now say, okay, this equation, let's call it y equals mx plus c. Call it equation 1. And equation 2, x minus 3 squared plus y minus 6 squared is equal to 50. We know that the distance, let me just draw this line from the center to the tangent. Now this is the tangent radius property. We know that the angle between the tangent and the center is always a right angle. Very important circle theorem property. It's called the tangent radius. Okay, so the angle between the tangent and the radius is 90 degrees. They're perpendicular. So if I said that the circle has center S, then I can say that the gradient of PS, okay, PS has gradients change in y over the change in x. Here's the y coordinate, so the change is 1. over the change in x, which is 7. Okay, very straightforward. So therefore, m, the gradient of the tangent, is the negative reciprocal is minus 7. We have that. We also know that y is equal to mx plus c, and that it passes through the point 10, 7. I can therefore say, okay, so y minus y1, blah, 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 and we have the gradient as minus 7. Okay, so when y is 7, let me put that in, 7 is equal to, we know the gradient is minus 7 lots of x, which is 10, plus c. And therefore, c is equal to 77. So the final answer, so y is equal to minus 7x plus 77. And now that is the final answer